In the case where we want to compare values of a numeric variable to a character or categorical variable, a question we may want to answer is, are the average values of the numeric variable the same across each category of the character or categorical variable? As we discovered last week, exploring and visualizing the data can help to shed light on the answer to this question. We used numeric summaries and plots to compare average life expectancies between countries classified as developed versus developing. The statistical test that best corresponds to this scenario is the t-test. As mentioned earlier, the data question that we're trying to answer with the t-test is, are the average values the same in each group? To perform a t-test in R, we need at least 3 arguments. The numeric variable is listed first, followed by the tilde symbol, then the character variable, followed by the name of the dataset. If you try to use a character variable with more than 2 categories, R will return an error. We will discuss how to handle this special case shortly and in more detail later in the week. In the output, we will look for 3 things: the average values for each group, the t-statistic, and the p-value. At the very bottom of the output, we will see the average values calculated for each group. We should already know this information from our numeric summary, so it's nice to see this information printed in the output as a check. In most cases, these averages will indeed be different from one another, but the t-test helps us to understand if the magnitude of that difference is statistically meaningful. Second, we want to note the t-statistic. We need to record this value so that we can report it along with the p-value as a way to indicate to the reader that this is the test that was performed. We won't interpret it further in this course. Finally, we want to note the p-value. Remember that our threshold for statistical significance is typically 0.05. If the p-value is greater than that number, then we cannot conclude that the averages in each group are statistically significantly different from one another. If the p-value is lower than 0.05, then we can conclude that the averages between groups are statistically significantly different from one another. In plain terms, we can discuss which group's average was higher and what that means in the context of the data. Let's practice performing the t-test in R. Now, we will revisit our investigation into the relationship between life expectancy and character variable status. Recall that we created box plots to understand the relationship between these 2 variables. What we are looking for is whether the box plots are in the same position and have the same length. Since the box plots don't show the average values for each group, which we will be comparing in our statistical test, we also plotted a bar chart to compare the statistic between developed and developing countries using the code here. Now, to make formal comparisons between the average life expectancy in developed versus developing countries, we can use a t-test. Recall that a t-test only applies if the character variable takes on one of 2 values or categories. The data question that we want to answer is, does the average life expectancy differ between countries classified as developed versus developing? That is the difference in the average life expectancies for developed countries versus developing countries equal to 0? To perform this t-test, we will use another base R function, t.test. First, we list our numeric variable, life expectancy, followed by the tilde symbol. To the right of the tilde symbol, we list our character or categorical variable, status. Finally, we specify the dataset as WHO. In this output, you want to pay attention to 2 things. First, at the very bottom, sample estimates of the average life expectancy for each group are given. These numbers match up with our numeric summary from before. If you manually calculated the difference between these values, there is a more than 10-year difference. The second thing you want to pay attention to is the p-value, which is given as p-value less than 2.2 raised to the negative 16th power. Because this p-value represents a number that is much lower than our threshold of significance, 0.05, this result is statistically significant. So in plain terms, we can say that in 2015, the average life expectancy among developed countries was significantly higher than in developing countries. While the bar plot showed the two values which we compared in our t-test, I prefer to use the box plot as my visualization of choice so that the reader can see the full range of data. In the code below, we will make the following annotations to the box plot. First, we will add in text summarizing results of our t-test. In this case, I will report the value of the t-test statistic so that the reader will know that a t-test was performed, along with the p-value. Second, I want to add in red points indicating where the average life expectancies for each group lie along the corresponding box plots. To further improve this plot, we could add informative titles that indicate that the red dots represent average life expectancy values for each group. The t-test is a test that compares average or mean values. There may be cases where the values of your numeric variable are highly skewed, such that the mean is not a good measure to use to describe the variable. There are other types of tests that make comparisons between other measures, like the median. We don't cover these approaches in this course, but it's important to note that other methods do exist and are worth further exploration. This can be extended to the case where your character variable can take on more than two values. Later this week, we will briefly discuss an approach to this test called analysis of variance, or ANOVA.